Okay, so chapter 3, guys, if you go to chapter 3, you're going to find, I counted, depending on how you do it, you can get up to between 40 to 50 different ways of wiring any system, any electrical system. Here's what I would like you to concentrate on for this commercial project. We're going to do, number one, EMT conduit. Number two, we're going to use MC cable. And number three, I'm going to use PVC conduit. These are the most, between these three guys, you probably have covered 95% of any commercial wiring system. Any commercial wiring system. A couple of things I want to tell you. Each one of these have its own article. So EMT conduits, let's talk about EMT conduits. EMT conduits, you're looking around here, and the advantage of wiring with EMT conduits, you can pull as many conductors as you can, as you are allowed to. So it allows you for future expansion. Using a conduit will allow you future expansion. So most of the time, you're going to use EMT conduits for feeders, definitely feeders and home runs. Home runs. So you have a home run from a J box right in this ceiling, from this ceiling here, and I need a home run all the way to the panel. Do you think what's the best way of doing it? Should I use a cable to the home run, or should I use a conduit? Definitely use a conduit. Why do you think that bringing a J box right in the middle of this room to this panel right here, a conduit would be the best scenario for this? Chris, future expansion, I can pull conductors. What's the alternative? The alternative is, what if I install an MC cable from this fixture box into that one? No problem, it will do the work, except it will limit your future expansion system. It will limit your future expansion system. So if you need your friend Chad's advice, when you do EMT, always focus on EMT, the home runs for branch circuits, as well as home runs for branch circuit, as well as the feeders. What's a feeder? All the feeders that we talked about in your project, guys, the 100 amp and the 200 amp panels, all of them, what did we say we're going to use? EMT. For branch circuits, all your home run branch circuit, just at least the home run branch circuit. Home run from the first J box in the ceiling all the way to the panel. That's a very good idea to use an EMT conduit. Now, can I use an EMT conduit for everything else? Yep, you can, for the lights and everything else. It's better, it allows you future expansion, many conductors and so forth. Cables, for the most part, is branch circuits. You're going to be using them for branch circuits. That's probably would be for MC cable, branch circuit. Though you can use it for feeders, but in a commercial building, a best application for it is a branch circuit. For example, I bring an EMT conduit from here to the center of this room into a 4 box, right? 4 by 4 by say 2.5 deep box. From there, I can take an MC cable and feed all these fixtures from an MC cable. Cheap, easy to install. That's application. So I can, from the same box, take another two and feed all these fixtures. Obviously, you might have to have multiple boxes to feed them. So that would be where an MC cable would be really a good application. Going from the main box in the ceiling to feed other fixtures. And I can put, from the same box, I can pull a wire, MC cable, right through these blocks and feed the receptacles in the wall too. That would be easier way. Though EMT might be a better option for anything concealed, EMT conduit might be a better option for that. Why? Again, future expansion and changes. PVC conduit, your option number one, guys, is underground. The only place you're going to be using EMT conduit, think about it, PVC conduit is underground. If you don't have an underground or wet location, don't think of PVC conduit. Always think EMT. Can I get you guys to get these three wiring? That's all what you want to focus on. EMT everywhere else, especially feeders, especially home runs. MC cable everywhere else for branch circuits from the first J box into all the conductors. Any comments, any questions about these three wiring methods, the most important ones in commercial?
When you're coming out of the ground or going into it, whichever way you're thinking about it. Let's say you're running up the side of the building.
Now,
going up high, you would stay with the PVC though.
we would use, in a case like this, if you're outside With the service, I would use PVC Schedule 80, or the best is rigid mill conduit.
So you can switch from.
Yep, absolutely. You can switch. You can have a fitting that take you from PVC into rigid.
Okay, and then obviously a good sealer.
Yeah, sealing and all this good stuff.
Okay.
But we're not rigid metal conduits. We'll talk about this one, guys. Think rigid only in two applications. Rigid. I'm not going to put it here. If you need physical protection for equipment, exactly what Nick just said. If I have a service coming along the wall here, this side of the wall, a service conductor or feeders, somebody can drive their car right into that conduit and bust them. Steel rigid conduit would be the best option for this scenario. Number one. Number two, in classified location, as in class 1, div 1, and div 2 location, where you have to. So these are, other than that, working with rigid will be pain, because we all know they're hard. We'll talk about this one in a second. Any question, guys, about these three methods? At least the three methods. Okay, so a couple of things when you guys read it. We have proper raceway or cable selection. I told you what I think the proper raceway and cable selection for a commercial building: EMT, MC, and PVC cable. Installation requirement for raceway or cables. Where can you use things? The installation requirement, two things, remember. If you are underground, always use PVC. If you're above ground, EMT conduit. This is the major division. Can I use EMT underground? Yeah, but it will rust. The code is vague about it, but it's not a good idea to use EMT or even rigid underground. Always PVC. Why? Rusting, corrosion. Select a proper size depending on the conductor. You guys have done that, and the metric designator, you've done it with me. The last part of the book talks about pole boxes and J boxes sizing. I know we did extensive pole box and J box sizing, guys, last quarter. I'm not going to do the calculation this time. I'm going to just mention the rules and stop right there. But when you get into a commercial building, this is where a pole box and a J box become a big deal. Sizing a pole box or a J box become a big deal. If you guys forgot how to do that one, I refer you to a really good pole box that we did, and there's a YouTube channel and the YouTube video in it. Really good. If you need help with sizing the pole boxes, I can help you. Not a whole lot to them. Okay, the proper sizing of boxes depending on the entry and so forth for calculation. A couple of things, guys, to keep in mind. Okay, so let me. I'm going to switch here into a couple of pictures I want to show you before we get into the details and all this good stuff. I don't want this one, and I don't want. Okay, I want this one. Okay. So what I'm going to do, guys. This is in your page. Could you please go to this one? I'm jumping around here. I'm going to go to page 126. Page 126, guys, give you an AC/MC cable comparing. The definition, the few things that you have, and I'm not going to get into all the details. I'm going to give you the most important things about this cable that you probably should need to know. The article is very important, so you can see where you can use them. You can use them in almost any look. MC and AC cable are interchangeable. The major difference between MC cable is more robust, better cable to use, and the grounding conductor is fully insulated. The grounding conductor is fully insulated. So that's a major thing. Number of conductors, you can get number of conductors. Basically, everything is superior, guys. For number of conductors, AC, MC cable, you can get a lot of conductors in MC cable versus very limited amount of conductors in an AC cable. Sizes, this is my favorite. Sizes, guys, look at the size that you can get it from in an AC cable. 14 through 1. Is number 1 AWG conductor a limitation of a cable? Yeah. But look at, if you're using an MC cable, look at the limitation on an MC cable. 200,000 kcm, that's as high as you can get. That's where MC cable becomes superior. You can get it in a bigger sizes. 4-aught, bringing on. 500 kcm, yep. 1000 kcm, yep, MC cable. So bigger cables, who cares? The question, who cares? If you are, later on, guys, if you're using a cable tray, and you don't want to use conduits. You want to bring cables in a cable tray. MC cable becomes a very good option. You can use a multi-conductor MC cable where you can bring 500 kcm, 4 conductors, 500 in a cable, sit it on that cable tray and shoot it all the way to the other end versus what? Putting it in a conduit and THHR. So it becomes a really very major option, MC cable. So that's superior. If you look at the color coding, guys, you can get in an MC cable, you can get a lot of grounds, multiple grounds. So there's a lot of important things in it when it comes to multiple grounds, multiple conductors, and so forth. Bonding and grounding. The grounding conductor in an MC cable is a fully insulated green grounding conductor. In an AC cable, there's an aluminum bare bonding wire that comes with it. Then you have to wrap it on the shield of the conductor in order to get you a solid equipment grounding conductor connection. So there is limited. That's where a lot of engineers don't like it because of that little thing here, guys. That little the fault and the wire, that little bare bonding wire. I work most of the engineered project. You wouldn't see an AC cable, an engineered project. You would see the minimum wire type that you use is MC cable. So these are a few things, guys. You can get them with multiple grounds, multiple conductors. You can get them. What I think I like about the AC, you can get them from 18 sizes, 18 all the way to, as we said, 2,000 kcm. And you can get them 5 kV rated, 15 kV rated, I believe. So this cable, actually, my friend, MC cable, if I have a medium voltage conductor system, can I pull an MC cable for this? Yep, bring it on. Can I put an AC cable for this? No, there's no AC cable medium voltage. So that's where I want you, being an engineer, to think MC as we move forward into that cable. Any question, guys? But they all look alike. When you look at them from the side, for the most part, they look alike, except the fully insulated conductor, grounding conductor with an MC cable. Okay, so that's a few things that I would like to mention about that boy. Okay. It talks about the sizes and all this stuff. Insulation, guys, if you look at the insulation here, it comes up to 600 volt. You can get insulation. And this is where another he has 90, okay, insulation. This is where another superior for MC cable. MC cable, when we size for MC cable, this, you can size it based on 75-degree column. This one, you're going to size based on 60-degree column. Anybody remember why AC is based on 60-degree column? Because the conductor goes up to number 1. And if the size up to number 1, you default to where? To 60-degree column. So that's a major advantage. Look at that, 60-degree column when we size conductor versus 75. That's a major difference, right? So keep in mind, and also, as I told you guys, this comes in 5 kV and 15 kV, so you can use them in medium voltage. Okay, so another advantage of MC cable, and I don't want to make an MC-AC fight here. Another advantage of MC cable, guys, you can have an MC cable that's rated for wet location. They have a jacket over MC cable rated for wet location. Most MC cable and AC cable are dry location. MC cable. So cover armor, you have a PVC outer covering, is available for use in wet location. Can you highlight that one? Wet location is a big deal. So you have an air handling unit. Take this, an air handling unit on the roof. And you need to tie to this air handling unit on the roof or rooftop units. You want to tie to it from a disconnect. Your options are liquid tight, flexible, non-metallic conduit, or metallic conduit, or an MC cable with PVC jacket on it. They make them. So these are really, so my point is, guys, it gives you a lot of options for location. And here's the disadvantage of this, dry location only. Look at that, dry. location and direct burial. Even you can buy in direct burial or wet location. You can buy one that you can direct bury it. So there's a lot of capabilities of them. If you ever go to a Rome cable or manufacturer, there's so many types of MC cable that you can get. So have I convinced you that as an engineer you're defaulting to what? MC cable. Why would they default to MC cable? Better equipment ground conductor, more sizes that you can get to, more amps from the same conductor based on 75, more locations covered by more locations, and so forth. Any comments, guys? Any questions about that? Comments, questions? Support. Look at the support, guys. The support is also superior. Support is when you support them. When you support these babies, everybody knows when we support an equipment. Support for AC cable, every 4.5 feet you have to support them, and not more than a foot from a box. And also as a fixture web, you can have a 6 feet. As a fixture web, you can have 6 feet. Same thing, look at that, not more than 6 feet of support and every 1 feet. Can you see it? 4.5, 6. So you have less work to do for supporting. So that's supporting the cable, and having no more, smaller conductors. And you can also use it as a fixture web. You can use it as a fixture web right here with 6 feet. And if you're fishing them, of course, if you fish anything in a wall, do you need to support that? Fishing anything in the wall, you don't need support. Yeah. So that's a couple of things superior for it. Here's where I told you the voltages, limitation of 600 volt. This is, look at that, 24, up to actually 35, I like you. Up to 35 you can get this cable. So that's superior, don't you think so? And again, I'm picking certain things from my knowledge, guys, that are very important for you as a designer to pick up. Connectors, a lot of connectors, armor cables, listed connectors. Both of them, they have to have listed connectors, guys, so not a big deal. You have to have the right connector for them. Ambicity, here's where 60 degree and we're 75. Highlight this one, 75, 60 degree and 75. Major thing for the ambicity that we talked about. Galvanized steel, aluminum armor cable with aluminum armor is marked as aluminum armor, or this one you can get it galvanized steel, aluminum cover conductor, and so forth. Okay, so these are the major things I want to highlight between these two cables. So have I convinced everybody as we are an MC people so far? So why on earth would you use an AC cable then? Why would you use an AC cable? Ashley, why would you use an AC cable over MC cable? Cheap. That's it. Cheap. If I'm going to throw probably 25%. If you don't know anything, 25%, probably more. For the same, all things considered. All things considered. Any question, guys, about these? So that's what I would like you guys to highlight. You asked this question, that's why I started right in this area. Okay, so with this, guys, I would like to go over as we go through. I know we have done, this is going to be a review for you. And I hope it's review because we have done a lot of them. When we size conductors, guys, when we size how many conductors fit in a conduit, well, before we do the conduit, let's go jump into the conduit arena here. Okay, give me 1 second here. Okay, let me see for the conduits that we're going to do. Wish we can have a way of, okay, I'll get into that one. Just going to show there's a conduit. I like the picture, guys. You can read the text. Okay, here you go. This is the one I'm going to start with. Okay. Now we talked about MC and AC cable, and we are MC people because of many things, right? Aladipo, my friend. Now let's talk about conduits. Let's talk about conduits. Now conduits, I told you, Chad told you guys, your option number 1 is EMP. Your option number 1, EMP. And your option number 2 for underground is PVC. But then you have IMC and rigid. So these are I'm going to say this is indoor This is underground. And things that I highlight are the most important things about this conduit. Indoor, underground. These two conduits, intermediate and rigid, for physical protection. Very important for these physical protection. And so if Chad is going to drive his, well, I used to say my Suzuki, now I have my Subaru, my wife's Subaru, right into a conduit, there's a possibility that somebody will drive a car into a conduit. Which option would you use? Rigid or IMC? No question asked. Hazardous location, rigid. So you wouldn't touch rigid unless you have a reason for it. I always say rigid is 10% of what you will use, if even, 10%. I would say EMT, you're going to have at least 90% of your conduit will be probably EMT. PVC underground, probably 20% if I will throw. They don't have to add up to 100, by the way. 20% of the time they're going to be using it. Any question, guys, about these conduit? These, the first IMC, rigid MC, RMC, and PVC and EMT. Questions? EMT is your conduit of choice, indoor. Underground conduit of choice, PVC. For physical protection, your conduit of choice is rigid metal conduit.
What's the key difference between the IMC and RMC?
Thickness and the sizes. Thickness and the sizes. We'll talk about it. Rigid is the largest, and there's three actually differences. The thickness of the wall, the rigid is more thick. They manufacture them in so many materials too. You can get steel, aluminum, you get brass, red brass, rigid. So they make them in so many materials, rigid, versus IMC and limited to steel. Okay, so that's any question, guys, about these before I go to the last flexible metallic conduit? So a logical. Where the heck would I use flexible metallic conduit? Everybody knows what a flexible metallic conduit. Do I have one here? Flexible metallic conduit is a conduit that's flexible, and it's a metallic, flexible metallic conduit. What do you do with this? Would you wire a building like Dunwoody with flexible metallic conduit? Yes. Would I call you below average if you do that? Yes. Is it the best wiring method for Dunwoody to wire everything, all branch circuits and feeders with flexible metallic conduit? No. The major use for flexible metallic conduit, major use, guys, is tied to equipment. Connect to equipment. Connect to equipment. Any question about that? So we have an air handling unit, right? And I have EMT conduit coming all the way right next to the disconnect to the on a wall, and from that disconnect I use a flexible metallic conduit for flexibility and to absorb vibration. Every time to have an equipment, guys, for the ease of using the equipment, moving the equipment, maintaining the equipment, and for the reason of absorption of vibration from the equipment. All equipments have some type of moving object, a lot of them, not all of them. So to absorb the vibration, you're going to tie it with the flexible metallic conduit. Now, who's going to tell me what the heck is this liquid tied flexible metallic conduit? Same as tied to equipment. The only difference with this one is wet and this is dry. Does that make sense? The major difference between these two conduits are the word wet, dry. Take this. I have an air conditioning, guys. Well, rooftop unit on the roof. Is this a wet location? On the roof, tying to it? Yep. It could rain and snow in Minnesota and everywhere else. Then when I tie to this equipment, what's my conduit of choice? To tie to the equipment, liquid flexible metallic conduit. Take the same rooftop units, and let's say I have a fan, indoor fan, right here, a fan, and I'm going to tie it to the fan because fan vibrates. I don't want to tie with it with EMT. Would I be able to tie it with an EMT? It's not a good idea to tie to it with an EMT because of vibrations. The whole EMT system will be vibrating. So what would be my conduit of choice for this indoor piece of equipment? Flexible metallic conduit. Can I guys get you to understand the difference between all these different ones that we highlighted?
Can you use that MC instead of the FM?
MC. Oh, yeah, thank you. MC cable. Yes, absolutely. Would I be able to use an MC cable instead of flexible metallic conduit? Yep. What's the advantage of using MC cable? You don't have to pull the conductors. What's the drawback though, is it might not have the size, well, I guess it's more expensive, put it this way. Really the drawback, because you can have MC cables any size you can imagine. But the drawback is it's expensive. Versus I can put this can get up to, here's another limitation that a lot of people guys don't understand. The 4-inch. The 4-inch is a lot of limitation for this conduit and this conduit and this conduit and this conduit. These are limitation 4 inches. So no matter what you need to do, if you have to use a flexible metallic conduit and you need a size 5, do we have a size? Do they make them in size 5? That's limitation. If I'm using liquid type flexible metallic conduit, limit to 4. PVC, no. EMT, limit to 4. Now this is where rigid becomes superior, as well as PVC. Can you guys see where rigid and PVC become superior? Here's an application where I must use rigid. For example, what if I need a size 5-inch conduit to pull my feeders? Do they make 5-inch conduit EMT? No. So what's your only option? PVC or rigid? Can you guys see a lot of people ignore this when you become being designers, and we design 4,000 amp switch gears, and a lot of us guys use 5-inch and 6-inch conduits all the time. So what's your only option? PVC, and by the way, PVC schedule 80 or rigid is the ones that goes all the way up to 6. Any question, guys? So everybody can see the limitation of these conduits, but up to 4, by the way. 4 is nothing to sneeze on. 4 can get you a lot of power. So any question about the use of, so there are two types. When we teach this for the apprenticeship, guys, we say there are 2 types of conduits. There is the non-flexible conduits and the flexible conduits. The non-flexible conduits, IMC, rigid metal conduit, EMT, and the flexible conduits are flexible metallic conduit and liquid type flexible metallic conduits. And there's another one, we call it liquid type flexible non-metallic conduit. Any question about all these? Nobody asked me about the ear, nose, and throat. Here, ENT doctor. I call this conduit is the ENT doctor. We'll come to this ENT doctor in a second here. ENT doctor. Any question, guys, about these are everything that you see on the, by the way, with rigid, this will cover actually probably 95% of commercial industrial buildings right there with these conduits, if you're using. Any question, guys? Everybody can see the limitation. The other thing I want you to look at the sizes that you can come up with. When we deal with, when you do commercial guns, it's not a good idea for blind circuit to use less than 3/4 of an inch. That's my opinion. So start at 3/4 of an inch and almost always end up with this. These are, you try to fit your design unless you have to go higher between 3/4 of an inch into a 4-inch. Obviously, you have a bigger feeder. You can use 4, 5, and 6. Why 5 and 6 are bad? Because they're limited in the type of conduit you can use. Any question, guys, about this? Without getting into the detail of every single conduit and how to support them. Nick, does it make sense? If you guys understand this, you're good to go. Okay, let me talk about the last conduit, least used conduit. This baby, your doctor, ENT conduit, electrical non-metallic tubing. You'll see a couple of pictures about it, the ENT conduit, guys. Look at the limitation on it. Number 1 is limited to size what? Number limitation. What's that? Limited to size 2. Where would you use this conduit? Where would you use this conduit? Huh? Hospitals? Well, a good application for the FC, you can use EMT conduit. Where would you use it where you cannot use EMT? That's my question. Because EMT you can use in hospitals, EMT. MC cable. Where would you use the ENT where you cannot use any other conduits? One application, guys, at the UBM that we had the engineer project, I wasn't the engineer on that. If you have a lab, an electronic equipment lab, and you want to minimize the interference with radio frequency, so you want all your wiring methods to be non-metallic, because metallic acts on an antenna and brings noises to your equipment. If you want to minimize the interference with the equipment, so all your receptacles here will be wired with non-metallic boxes as well as non-metallic conduit. this becomes an interesting way of wiring. You can wire the whole building with non-metallic. It's a non-metallic ENT, electrical non-metallic tubing, as well as the boxes are non-metallic. So the only metallic thing that you have is the hots and the neutral bringing the power, and the equipment grounded conductor, which is insulated and tied all the way to the surface. So that's a good application where interference is a big deal. Another good application where this becomes an option is if you have a highly corrosive environment. Very highly corrosive. By the way, every time, Phil, you have a highly corrosive environment, non-metallic wiring methods become superior. All the time. Every time, highly corrosive environment becomes superior. That's why we underground PVC. Let me give you an example, guys, not for ENT, but for PVC use. Wastewater treatment plants, they have a lot of gases that they use there, and you use rigid there or EMT, it will eat that baby. You wouldn't find it after a couple of, well, maybe 10 years, it will be completely rusted. So what they use in these applications and wastewater treatment plants, because they need the rigid for physical protection, and they need the corrosion protection, so they marry the RMC to the PVC. Literally, they make a PVC coated RMC. They call it PVC coated RMC. They have a rigid metal conduit and they coat it with PVC. Why would they coat it with PVC? Because of corrosion. So anyway, so this baby, corrosion as well as interference. I don't know if you can read. Corrosion as well as interference. Radiation labs, anything that need interference to minimize the interference. Any question guys about these conduits? Yes, sir. These are like, they look, guys, you'll see a picture of them. They look like flexible metallic, non-metallic conduit. They are flexible. They're not, we can't buy them in pieces, but they're flexible ones. When you push them, pushing conductors through them is a nightmare. Pushing conductors through any flexible conduit is a nightmare. Unless it's 6 foot fixture web. I wired, because I was so lazy, I don't want to build conduits because I don't like building conduits and I'm not good at it. So I wired right here in Minneapolis a couple of fixtures and lights in the basement with flexible metallic conduit. Can I do that? Yeah, no problem. The problem is pushing the conductor through that baby is a nightmare. It's not worth it. Pushing conductors, because you have to put your fish tape in there, and God forbid you use metallic fish tape in that one, wouldn't move. So you have to use non-metallic fish tape, especially in these, and you have to pull all these conductors. A really nightmare to work on it in longer distances than, I would say, 10 feet. Higher than 10 feet, it becomes really nightmare to work with it. The same thing with this. And you actually, this one has an ENT, you can bust that one if you push too hard on it. This is non-metallic thin. But when you use them, most of the time when they use them in short parts, 10, maybe 15, 20, and then they go to a gearbox. And they keep moving with them. You're not going to pull 100 feet of this and pull the conductor inside it. Any question, guys, about this? Any question? So that's what I thought to start with this baby. Okay. All right, so with this, I'm going to take you guys back into, there's certain things I want to, so we know what the conduits and the cables that we're going to talk about. The second thing I'm going to, just a couple of nice pictures to talk about. If you're an electrician, open your ears here. If you're not an electrician, don't listen to me. There's something called running threads. Running threads, the advantage of them, guys, if you're butting a conduit to another conduit like this, how are you going to put the connectors? That's a good application for running. So you're butting them to you're against the wall. You're limited in the space. How would you do that? A running thread would work. The problem with running threads is running threads, they call them. You can move this one all the way up, move it all the way this way, all the way up, all the way this way. The challenge with this one, it doesn't give you a good connection. What do they call it? Equipment grounded conductor connection. not. So that's the disadvantage of it. So be aware of this. Running threads not permitted for connection at couplings because they don't give you. And I don't like to emphasize that one because it's for electricians. They don't give you a good equipment grounded conductor. Okay, bending. You guys are not electrician, but you should be able to understand if you're using EMT, they have to do some bending. Bending, you've seen that EMT conduits, you can bend and, gosh, we have one in the lab right now up to 2 inches that we can bend. EMT, you can bend 2 inches, oops, 2 inches EMT. Usually you can bend, if it's a bender, you can bend 2 inches EMT, then an inch and a half rigid metal conduit. Good luck doing that. So anyway, this is just be aware, guys. I don't go over this one with the designers. There's a couple of ways you have to be aware when you bend the conduits, the location of how to bend the 90% stub ups and so forth. You guys are not going to be bending, but be aware that's a hand bender's a pride among electricians when they work on bending conduits. Hand bends. Don't think of bend. A lot of companies, guys, don't even bend anything larger than 1 inch. They don't bend it. Larger than 1 inch, don't even mess around with it. So you end up bending, most of the time, you end up bending 1/2 inch or 3/4 inch. These are good application for 1/2, 3/4. You go to 1 inch, you're almost there, but you go higher than 1 inch, it really doesn't pay from a lot of companies to bend them in the field. They pre-manufacture them already bent, EMT or rigid. Just takes too much time. Okay, when you come, this is interesting because it came in 2011 and even before. If you bring in feeders from the underground, you have to seal. You have to seal right here or at the same location, either one location. You're bringing a feeder, most likely coming from underground. What do you think the conduit would be? Your conduit of choice, PVC, always underground. You're coming from underground into the switchgear, guys. You're going to be, by code 2011, you have to seal either or both ends. The reason, because they got tired of creatures crawling right in here inside the switchgear and shorting 4,000 amp switchgear and dropping a hospital out of business. So you seal for the most part for animals, and because the temperature is not a whole lot of temperature from underground to above ground. But for the most part for creatures. That was changed in 2011, as a matter of fact. Seal from different environments. It has been there for a long time, guys. Okay, here's a flexible metallic conduit. This is a perfect application of flexible metallic conduit. Location, guys. A fixture, sliding fixture, you come from a gearbox right in here and you tie it up to 6 feet. You do not need 6 feet, you do not need a support. So when we design a system like this, if I have a room like this, and I'm going to bring my conduit system here, here's my conduit EMT, I put my box here, another box here, these are my gearboxes. And suppose that Ashley designed it and she put one fixture here and one fixture here, and I'm gonna make them match, but they don't have to really match. Here's 8 fixtures in a room like this, and I don't want to wire them, right? I want to wire them. So one of the application, I don't want to say the best, one of the common wiring method is to bring an EMT conduit, guys. This is your EMT conduit, 3/4 inch. 3/4 inch with all your conductors. This is my J-box, 4x4 J-box in the ceiling, and from there you fixture with these babies, bam, 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 and here. So you fixture with these fixture like this. You bring a fixture web. They call it fixture web. What's a fixture web? 99% of fixture web is going to be flexible, flexible metallic conduit. Flexible metallic conduit. And you put your conductor inside it, and up to 6 feet. Here's the advantage: up to 6 feet, guys. No support, and you don't need an equipment ground conductor. So you just put 2 wires inside that baby, and you fixture web it. You can go as low as on a smaller 1/2 inch or 3/8 even for remanufactured wires. But for the most part, 1/2 inch, and you go with 2 wires, bam, bam, to every single fixture. A lot of fixtures come with a fixture web with it, pre-manufactured fixture web and wires coming out of it, fixture web and 2 wires, and just tie it with 6 feet, and you just tie it to your box. What's the advantage? Ease of installation of these systems. So can I get you guys to understand flexible metallic conduit is tying to equipment, lighting fixtures, and mechanical equipment? Can I get thumbs up? Yes, Chad, we got that one. Okay, so that's a good example of using it. Here's you guys, we talked about this all the time. Um, Tying to equipment, all that's flexible metallic conduit. Tying to equipment. When you tie to equipment, you can go from, look at that. There's a coupling that take you from EMT into flex, or you have to go through boxes. When you tie to equipment that vibrates, does the fan vibrate? I mean, the light here vibrates? No. For the most part, no. But if I have a fan, when you tie to anything that vibrates and moves, then you have to pull an equipment grounding conductor inside it, like this one. So when you guys tie, that's the difference between a fixture whip like this, tying it with a flexible metallic conduit, or a fan. A fan, you have to pull 3 conductors if it's single phase, hot, neutral, and a ground, inside the flex. We talked about this one, guys. There's I would say, I would dare to say just 6 inches. There's also how far you can support this one to the fixture. There's from 6 to 4 inches, depending upon the size of the flex. So basically, I can support this box here and move 6 inches, 6 feet, and I still don't need to support that cable. So it allows you to move things and flexibility. So if I can get you to remember, guys, this is flexible metallic conduit, or flexible or liquid, or the second one, liquid tight flexible metallic conduit. Liquid tight flexible metallic conduit. Where would we use liquid tight? Wet location, flexible, dry location. Done. Tie to equipment. Why do we tie to equipment? Ease of working installation and absorption of vibration from the system. Here's a very good example of how you come up with an EMP conduit. So very good example, you come up with an EMP conduit in the top going all over here to the service, right? You put your disconnect here, controller, and you feed. When you come to the controller, then it's not a good idea at all to go EMP from here to the motor. You would never do that. So you go to the flex. I want to remind you of one little thing here. Can you guys see the equipment ground conductor? 3-phase conductor. So inside this conduit, there will be 4 conductors, number, I don't know, whatever the size is. Based on this one, there will be different numbers because it's 100 amp. So let's just say 4 conductors, 3 conductors, number 1 hot, and 1 conductor, number 8, inside that conduit. Any question about flexible metallic conduit? If it's outdoor, the only difference would be liquid tight flexible metallic conduit. Done. Any comments, any questions? For those of you who like Phil and Jackson, my friend, when you work for Elliott, this is what you're going to be installing. What you're going to, the engineers stop at wiring and disconnect right there. You guys are going to be taking into consideration the flex, size of the flex, and how far the flex is going to go from here before you support it. I'm telling you, you can go based on the code from 4 to 6 based on the size of the flex.
So for grounding and bonding, just to clarify because I don't know.
Go ahead.
Motor has to be grounded, right?
Mm-hmm.
Are you running the conductor through it?
Yep, right here.
Oh, I see.
You see that green here?
Yeah.
It's a 3-phase only. So that conductor is a ground, not neutral.
What about
Here?
does the flex need to be grounded?
Yes. The flex have to be grounded. So you have to have a special type connectors. Big deal, guys. If you're gonna get confused, what type of connector goes with what type of fixture? There's a lot. So yes, the connector here and the connector here have to be rated for the flex, and they ground the flex. So in reality, you're gonna have 2 grounds. Really. 1 ground going through the green wire and 1 ground going through the flex shield. But why do we need 2 grounds? Because of flexibility. If you get rid of that one here, when this vibrates, it wouldn't give you reliable ground. By the way, it will trip 95% of the time. But for that 5% of the time that wouldn't trip fast enough, it could be dangerous. I guarantee you, if you use a flex right here and you go short face to face, it will trip. but there's 5% of the time where the short circuit might be, the current will be low enough that cannot push itself through the flex because high impedance. The flex get you high impedance.
So are
No.
you pigtailing the grounding conductors one
No,
piece of
the
equipment?
connector itself here will ground the flex
Because-
to the box.
Because the box is grounded.
Thank you. Because the box is these, yeah, it will be housed this side to this jet because these are all tied together here. Yeah, you're absolutely right. No pigtailing. Any question, guys, about this? Any question? So let me see what we have here. How about if I give you a quick break here, and then we'll continue. And I'm hoping, so if you're using, Phil, my friend, if you're using PVC, especially PVC conduit, this applies for all other conduits. If you're using PVC conduit, you have to pay attention to the expansion of the conduit. So take this. If I have a conduit going from this wall to this wall, this conduit here is 4-inch PVC schedule 40. Outside, exposed to the elements in Minnesota, the temperature that we get in Minnesota, the highest temperature, the highest temperature for calculation, I think they used 92 degree Fahrenheit. The lowest temperature, minus 20, I believe, minus 20 Fahrenheit. Again, these are for calculation purposes, for calculation. So look at this. Do you guys agree with me? If you put a conduit in an environment that's it's gonna change from 92 Fahrenheit into minus 20, so that will give you a range of 112 range of temperature. Do you think the PVC is going to expand and contract? Most of the time, you're going to find, if you ever been in a situation, you can find the conduit here and the box here, and in between there's a wire, because it expanded far enough. I mean, it's contracted far enough that it moved away from the conduit. The smarter than Chad, be aware of this. If you are a contractor, this is a big deal. When you have runs of PVC conduit, they have a little piece that's called expansion fitting here. So that you have to put the expansion fittings for every 50 to 100 feet of runs, you have to put an expansion fittings, and it's size based. The expansion fitting is size based on the temperature variation in this area. So again, temperature variation in Arizona will be completely different than the temperature variation in Minnesota. So be aware of that expansion fitting. So what does that happen? If you guys look, this conduit, they allow it loose with this piston. So in the winter, what happened in the winter for the conduit? It shrinks. So this will come this way. And still enough, that piece is the one that's going to, so it's still enough when it comes this way, it's still enough and still connected. In the summer, it's going to expand, go that way. And if you size it right and you install it right, the conductors will never be exposed. Any question, guys, about the expansion fittings? We test the masters and the journeymen on how to size the expansion fittings in Minnesota all the time. So that's a major topic. But I'm going to save you the time of doing the calculation for that one. We'll talk. This is the wiring method, guys. The ENT, your ear, nose, and throat. ENT. We talked about this one, guys. Look at it. It looks like flex, except it's non-metallic. This is your ENT, electrical non-metallic tubing. It's a tubing. You pull your wires. This is non-metallic. So what do you need to pull? An equipment ground conductor with it. Where would you use it? Interference or highly corrosive environment. A good application for this. Limitation on this conduit, if you guys remember, it's 2 inches. You can't go higher than 2 inches. So good luck getting anything higher than that. So I thought that's just a couple of pictures of using it, and I'll flash it. A couple of support. You guys don't get into, if you become a project manager, you get into the hardware of support of conduits and so forth. This is my favorite. Supporting of conduits. This is only if you're going to be a project manager. If you're an electrical design in a designing firm, guys, you never pay attention to this. But if you're a project manager, look at this. If you have an EMT conduit, you have to support it every 3 feet of every box. Every 3 feet of every box. Can you guys see that? The support right here. If you have an EMT conduit, the same thing. EMT support, and at intervals. The intervals of EMT, guys, here's another box here, every 3 feet, and at most of the time, 3 feet from every box and 10 feet in between. For most of the conduit, with some exceptions, I'm not gonna get into the details, but for most of the time, first, you walk into any conduit, make sure it's supported within 3 feet. This one right there, it's supported within 3 feet, right? Within 3 feet means 3 feet or less, and every 10 feet intervals. If you have an MC cable and an AC cable, guys, within 1 foot, remember how we said, especially with MC cable, within 1 foot and within 4.5 feet support, depending on the size of the MC cable. But remember the 1 foot, can you guys see the support 1 foot from the enclosure and at an interval of 4.5 feet, 4.5 feet intervals and 1 foot in between. So just remember, so I want to get you to remember 4 numbers. If you have a cable, a foot from the box, you have to support the cable within a foot and at 4.5 feet. If you have a conduit, at 3 feet from the box and 10 feet in between. There's some variation though, but that will cover 80% of the support of cables and conduits. 80%. Now, who cares if you're an electrical designer at Michelle Cool Erickson? Nobody. If you become a project manager or if you go in the field and you are to sign off on certain things, then you have to be aware of that. This is just to tell you guys, equipment grounding conductor. I believe why we pulled the equipment grounding conductor in the same conductors, because they minimize the electromagnetic effect. To bond, you told me about this one here, my friend Chris. Nick. When you have conduits like this, guys. If you have reducer, anybody knows what the reducer washer? These little things here that reduce the hole to match the conduit. Can you see that? The hole is bigger than the conduit in the box, so you have to have these reducers. When you use that, you have to have 2 lock nuts in order, one inside, one outside, threaded conduits or EMP fittings. So what you need to do is, this will basically get you a good equipment grounding conductor out of this conduit, especially with the reducers. I want to spare you the whole equipment bonding, couple of boxes. Most of these guys boxes, yesterday we were talking about this one, you're going to have knockouts from 1/2 inch to 3/4 inch. Most of the time you can have a 1 inch and bigger ones knockout. So when you design your system, when you design a box like this, if your conduit is going to be 1 inch, be very careful. You might have to find a special type of box to do it. Make sure when you design a box for receptacles and switches, stay within a conduit of 1/2 inch to 3/4. This is a great design. Otherwise, you might have to find a special box for it. Knockouts for different type of concretes and boxes. I'm going to spare you guys for use mud rings and square raised covers, guys. So if you have square boxes and so forth, you need to pay attention to different application for these. And I'm going to spare you the conductors. Box fill calculation, and we're not doing box fill calculation because we did it before, guys. If you have a raised a plaster ring like this one, where you're going to put your shear up around there, you're going to add the cubic inch of the box into the cover. The box and the cover have to be added together when you size how many conductors you can bring to this box. We did that one last quarter, right? You guys remember that one? When we have a raised cover, it gives you more room, so you have to add the room that's specified with that raised cover. Get that one. Okay, equipment grounding conductor. One conductor. A couple of things, guys, when we talk about equipment grounding conductor. This talks about what counts and what not count. I want to emphasize this one. This is the best picture I ever had. If you have a loop like this, and the conductor loop or coiled less than 12 inches through the box, it counts as 1. So remember that loop we talked about? What I like about these are the pictures that comes with them, guys. If you loop it 12 inch or more, it counts as 2. If you loop it less than 12, it counts as 1. If the conductor is going right through, it counts as 1. If the conductor is spliced, it counts as 2. All these variations, and I want you guys to look at them. and I'm not going to go details on them because we've done it in the residential, and I think it was a good application for it. Pole boxes. Pole boxes, you have a pole box like this. Anybody knows what the definition of a pole box? When does a box become a pole box? When you bring an insulated conductor of number, anybody knows? More than 6. More than 6. Number 4. Every time, Ashley, you bring an insulated, not bare, not covered, insulated conductor of number 4 or larger, this box become a pole box, okay? And for the pole box, there are rules, if you guys remember. If you're pulling the conductors this way, the conduit, this size becomes 8 times the diameter. Can you guys see that? If you're pulling a straight pull, 8 times the diameter, right? Piece of cake. If I'm doing an angle pull, which like we did last time, we don't have an angle pull. Let's say there's another conduit here, and I'm going an angle pull. Okay, then this distance here, and I'm going to make this one, this, and this is, let's just say this conduit is D1, and this is also D1, the same size. This becomes 6 times D1, and also this becomes 6 times D1.
It's the outside diameter
Plus,
of the conduit?
Yep. The outside, well, the trade size. The trade size. The trade size. I'm sorry, the trade size. This one plus all the other conduits, plus all in the same wall, also plus all in the same wall. Remember that? Plus all the conduits in the same wall. Plus all the conduits in the same wall. Please, guys, if you want to go, I encourage you to look at the example that we did. We have a really nice example that we did, and it's on YouTube now, with multiple conduits coming all over and all the calculation for it. The only thing I want to emphasize, if you're going straight, it's 8 times the diameter of the largest conduit engaged in the straight. If you're going with an angle, it's 6 times the largest diameter engaged in the angle, plus all the conduits sharing the same wall. If you're looking at this one, you're looking at this wall, nothing is sharing. If you're looking at this distance, you're looking at this wall, then there's another one sharing. And the U, if you have a U-pole, you guys remember the U-pole? The U-pole right here, going this way, then will get you a distance is 6 times the largest, times largest, plus all others sharing the same wall. And again, I'm going fast through this because we went to it, sharing the same other wall. And of course, the distance between the conduits sharing the same conductors here cannot be less than 6 times the diameter, D1. When Ashley goes and drill a hole in the box so you can put this conduit, you have to make sure your holes are not closer than 6 times the diameter of the 2 conduits. And I'm going to stop at that one, guys, for this without reviewing the whole conduit stuff. Here's the 6 times D. There's a nice pictures. Can you guys see how the 6 times D, this is probably one of the nicest pictures they have. Here's DD, one at a time, 6D. The only thing they don't add here, they don't add plus all others on the same wall, and here plus all others on the same wall. In this case, there's no all others. Is there? There's nothing. So make sure you add plus all others on the same wall. This one doesn't have all others in the same wall. Any question, guys, about the pole boxes? So this chapter talks also about sizing junction boxes and device boxes and pole boxes. And we covered that one. Okay, the distance between, a couple of examples here, guys. Take the distance between, I don't want to go the calculation. For example, if you take, this is a 3-inch. So if you take the distance here, 3 times 6 equal 18.
What happened to the 8D that you just had?
The what?
The 8 times diameter.
There is no straight pole.
Oh,
That's straight pole. I have a feeling that you need to add plus all other conduits, so plus all in the same wall. So that will give you plus 3. right? What is it? This one in article 214, not 28, 214, 28. Three, 3, 12, 314, 28. Okay, angle with slices, blah blah blah. 6 times the largest diameter of the largest raceway in the same row. The distance shall be increased for additional entries by the amount of the sum of the diameter of all other raceways entries in the same row on the same wall. Yeah, you have to add a 3 for this one, guys, because there's not the conduit here, so they'll give you a 3. They'll give you what, 18 plus 3 is what, 21? 21 inches or inches. And then the distance between the conduits are always 6 times the largest conduit. Any comments, guys, about the pole box? We're not using a pole box in this project, but really pay attention to the 6 times the largest conduit if it's a U or angle pole, and 8 times the largest conduit if it's a straight pole. And there's a couple of good examples that we have. This is the distance between them, and I'm going to move on into the threaded. A couple of things, guys, about fittings for threaded conduits. Okay, connectors. This connector, guys, since you're using EMT, please get used to, here's a connector right there. They call it set of screw connectors. This is the 90% of the time you're using a set of screw connectors with EMT. That's the connector and the coupling that comes with an EMT conduit, always. They call it set of screw because you have set of screws and you tighten them from both sides, you get your connection. And if you want to tie to a box here, if you want to tie to a box here, piece of cake, Chad, and if you want to bring a conduit in here and a conduit out here, this is a couple two connectors together, two conduits together, and a connector that couple or connect the conduit into the box. If you're a project manager, it's a good idea to understand that one really good, especially that particular one, because these are compression connectors, guys. If you're outdoor actually and using EMT above ground outdoor, these are the connectors that are going to be connecting to. Compression connectors. These are watertight. So if you're using EMT outdoor, make sure you use this type of connectors. Again, you guys are not electricians, but be aware of that one outdoor in a wet location. Different type of connectors for different application. Stub-ups and back-to-back connection, guys. Here's what I thought a good example of where liquid tight flexible metallic conduit. Look, the typical example of how to use liquid tight flexible metallic conduit to tie to an equipment. You'll see that a trillion times, guys. In the past, you used to be able to use flexible metallic conduit here. Now you have to use liquid tight flexible metallic conduit to the disconnect from the disconnected equipment 100 times. This could be on the roof, could be anywhere in a wet location. Had this been in a dry location, the only thing that comes that you don't have to use is liquid tight. Flexible, you can use flexible metallic conduit, not liquid tight. You don't have to if it's indoor. Here's another picture of it. This is just a couple of pictures about MC and AC cable, guys. Here's an MC cable. I don't know if you can see the ground here. The ground. What they did in AC cable lately, they did a lot of. This is also an AC cable, MC cable. In MC cable lately, they had a lot of configuration of it, guys. So the AC that a lot of us are used to, I mean, the MC cable is the one that has. I don't know if you can see it here, an equivalent ground conductor fully insulated. But there are different configuration of an MC cable that you can use. A lot of supports. Different type of hardware for the project managers to pick from. Connectors. We talked about this conduits, diameters. Okay, let's go back. Here you go. The last thing, guys, is about how to size conductors. When we size how many conductors fit in a conduit, I hope by now, guys, we know how to size that one. There are two tables, very important. Table number 1 is table 4, right? Table 4 and table 5. Table 4, guys, if I have a 4-inch conduit and it's 99% of the time you're going to be here and you're going to use, this is the available space that you can fill in an EMT conduit. I will remind you, this baby is for EMT conduit. If you're using rigid, if you're using the ear, nose, and throat doctor, you're going to go to the one underneath it. So be aware when we size conductor, again, this is quick review, and I know that all of you guys know how to use it. Table 4 gives you the allowable space that you can occupy in a conduit. And table 5 will get you the cross-section area of the conductors. Okay, you can see there's a lot of IMC. If you're using IMC, here's the conductors for IMC, LFMC, A and B, different types of that conduit. Rigid is here too. And all the other conduits. PVC is right here too, if you guys can see for your PVC stuff. And the last table is the cross-section area. This is table 5. Table 5, this is just a view of table 5, guys. If you have a THHN, and this baby is number 10, the cross-section area square millimeter KMS. Here's the cross-section area of one conductor, THHN, from table number 5, chapter 9, table 5, chapter 9, table 5. Can you guys assure me, Chad? Yeah, we know how to use these conductors because we have covered it. This is quick review. And if you don't know it, if you graduate from here without knowing how to use these tables, call me for a refund. So it really is a big deal. Okay, so this is my PVC. This is a nice, let me see if I can flip that one here. Help me with the flipping here. How do we flip this one? View. Should be able to flip it, wouldn't we? No, not this one. Okay. All right. Email, print view, open. Okay, if you guys can look at the table, this is a really nice little table comparing all the stuff that I talked about, the EMT conduit and so forth. And then this is where, okay, can you guys go please to page 137? 137 has a nice table that compare between the EMT, the IMC, the rigid, the PVC, the EMT, the FMC. These are the most common ones. We know about the sizes. All of them are limited to 4, except rigid and PVC can get them to 6. Spacing, 3 feet for the most part, 10 feet. Flexes 12 when you support from fixture. Uses permitted. I told you guys you can read through them, but I told you if you're underground, wet location, in a underground PVC, other than that, EMT, unless you have physical support, physical protection, and rigid. So expansion fittings and so forth. So a quick description of these conductors, these conduit systems. The box fill, guys, and I'm running with that one. Everybody knows this table, and if you're bringing, this becomes really cool. Now, Ashley, my friend, because when you use square box, suppose I'm going to use a square box, the deepest, a square box, this one, guys. Look how this becomes a big deal in square box. And here's my square box, right? Here's all the openings of my square box for the most part, right? A square box, and it's used a J box. This is very, very powerful in commercial, guys, because you're using in the ceiling as a J box, just J box. Look what happened. When you have the J box, all of them are number 12. 99% of the J boxes in commercial, number 12. Look what happened. How many conductors do I need? Always number 12. And how many conductors I can bring to a J box? Typical 4 by 2.5, typical J box in the ceiling, 13. Look what that 13 can give you. Just to give you an idea, guys, all the equivalent magnetic conductor count as 1, so I don't have to count them. So that will give you, if you take 1 as an equivalent magnetic conductor, that will leave you with what? 12 conductors. 12 conductors. So if I want to go with 12 conductors, 1, 2, 3, we have 8, 1, 2 times 4, 8. 8 times 2, 16. I have just exceeded the how many conductors I can fit in this box. Can you guys see that? Everybody can see that? If I had to pull, that's why if you have a fixture, it's a good idea. If you have a fixture like this, you bring one here, and one here, and one here, and one here. Because suppose that the fixture would have a number 12. So this is 2 number 12. So 1, 2, 3, 4 times 2, 8. I can bring 8, and I'm limited here to 12. I have four more fixtures to pick up. 4 more fixtures to pick up. Here's another fixture here, and another fixture here, right? And another fixture here. Well, 4 means 2 more fixtures, not 3. Okay, so look how many fixtures. 1, 2, 3, 4, 5, 6. I'm almost limited to 6 fixtures out of a J box that I can pick before I exceed how many conductors can fit in this box.
So they have to operate in electricity.
You're absolutely right, because I need to drop one because I need a supply. So how many conductors did I need? Yep, because you need 2 for the supply. Then 1, 2, 3, 4, 5 fixtures. That's why if you limit yourself to a 4 from a J box like this, you're good. Does that make sense? When you guys, especially when you're doing the takeoff for a project, you put a box, limited to a 4 fixtures coming out of it, you're good to go. You don't exceed. Otherwise, what happens if you exceed? You're getting into a bigger boxes. If I want to go to the deepest, biggest square box that I can use as a J box, I can go all the way up to 18. Typically, you limit yourself to 4 and you work with them. But if you want the bigger boxes, you can, if you are in this situation, you have another option, but no more than 18 though. And I'm talking about the J boxes right above the ceiling, guys, that you bring the EMT conduit to it, and you feed all these lights from it. See how this becomes very handy without doing any calculation, because J boxes have nothing in them. They're EMT, so all what counts is the conductors. All what counts is a conductor. And as a matter of fact, you might have to be very careful, like you said, because you have a conduit coming in and a conduit coming out, and you have 2 conductors in this conduit and 2 conductors in this conduit. That's why you are limited to a 4. 1, 2, 3, 4. 4 lights, because you have 2 conductors in and have 2 conductors out to go to a different location. 4 fixtures from 4 fixture web in a J box is a good limit to use as a design. Does that make sense? So you start right here. If I want to bring an EMT conduit and feed from it, put J box here. 1, 2, 3, 4, done. Move on. Some fixture webs, guys, have a smaller wire size, so might give you advantage of like number 14 and so forth. Any question about this? Any question? Okay, and you guys, we did the whole number of conductors and so forth. Okay, the last thing I want to show here is just go room into the NEC code book, if you don't mind me, and walk you through the EMT article when it loads. Come on, bud. Any question, guys, about MC cable, EMT, and PVC? That's all what I want to constantly focus on. Really, these 3 wiring methods. Let me just walk you through all these wiring methods, not all of them, but a good example. If you guys are not familiar with the NEC code book, if you start from, look at the MC cable right here. In NEC wiring methods right here, you're going to have tons and tons of approved wiring methods that we use in the NEC code book. Start with the AC cable article. I'm going to go to the MC cable. I'm going to walk you. All of them are the same. So I'm going to go all the way to the MC cable. Can you guys see all these wiring methods? Let's go to the MC cable. If you're in the MC cable department, did I use the medium voltage? MC cable, didn't I? Okay, go back. Medium voltage, here we go. MC cable. The first thing you're going to encounter, guys, when you use MC cable is, can you guys see that dot here? This article always end up with dot 10. If it's done dot 10, that will tell you where can you use this wire methods. Uses permitted. For service, look at this. Service branch. This is one of the major ones that you can use. You can use it for service, feeders, and branch circuits, and it goes all the way. So whereas you can use it, direct buried, all the way. I want to go all the way. Why can't you use it? Not permitted. We're subject to severe physical damage. If Chad is going to drive his Suzuki into it, you can't use this cable. So this is very, very important, guys, to know that dot 12 is used as not permitted, dot 10 is used as permitted. And we talked about, I don't want to get into all the itty bitty of it, guys. I told you where we use MC cable in dry location, unless if you're going to use it in wet location, it has to be rated for that. And it talks about the bends, how many bends you can use through it, and so forth, shield, and so forth. Support, how do you support it, guys? We talked about the supporting, securing, and support 6 inches, provided shall be secured at intervals of 6 feet, as well as 12 inches from a box. And more details about this ambiguity. Here's what we got the ambiguity, guys. Dot 80. It says ambiguity for the conductors are going to be used based on 310.15, and you can use up to ambiguity shall be determined from this table 14 and larger from table this for cables. And if you guys go to, if it's more than number 1, you're going to be sizing it from 310.15 B16 under 60-degree column. There's higher than 600 volt, guys. You also go to different tables if it's higher than 600 volt. Construction over 600 volt and sheath and so forth. So it's not a whole lot to it. But in my book, the most important things, guys, is dot 10, where can you use it? Dot 12, where cannot you use it? And always being engineers and designers, we always look at point 8. What's the ambiguity of these conductors? What's the ambiguity of these conductors? Any question, guys, about this? Typical article in the NDC code book, typical article. I'm going to take you quick and then I'll let you go to, this is a cable. Let's go to MC EMT conduit. Help me here, EMT conduit, EMT, right here, 358, EMT conduit. If you guys go to the article EMT conduit, EMT conduit, this will be in yours, page 218. EMT conduit, they describe it as thin wall conduit, surround, and so forth. Uses permitted. Here's my favorite. You can expose that baby or conceal it. Corrosion protection, you have to have some type of protection if it's in corrosion areas. Wet location, can I use it in wet location? All support faults, blah, blah, blah. You can use it in wet location, but you shall be corrosion resistant. Any wet location, guys, is exposed to corrosion. You have to be very careful, though it's not really a wet location conduit, but you can use it outdoor, above ground, in a wet location. Use is not permitted. We're subject to severe physical damage. You can't use that baby. Corrosion solely, where we have some corrosion protection only, this type. In concrete and cinder, so it's all about corrosion here. In hazardous classified location, good luck. Sizes, 1/2 inch for the most part, 4/4. Number of conductors, you have to go to the tables. Bends, 360 degrees. Reaming, and when you cut them, you have to ream them. No threading for this conduit. And the last thing, that's about it. For there's no conduit definition, EMT. Sizes that they can come up with, and support. Where's my support? Support, here's my support, guys. Very interesting. Support every 3 feet and 10 feet intervals. Here's my 10 feet interval and every 3 feet from every box. Grounding, can I use this conduit as a grounding? Yep. Why do you use it as a grounding? Because it says shall be permitted as an equipment grounding conductor. Any question, guys, about these conduits? So I don't want to walk you through each and every one of them, but typical if you pay attention to point 10 and point 12 and point 80, guys, and whatever article, these are uses permitted, uses not permitted, and the ambiguity typical. I said there's close to 50 wiring methods in this code, guys. You're going to be using them as needed, dipping in. You are not, if you were sitting for a master exam, we go deeper into where to find things, but when we test the Minnesota course, when we test for masters and journeymen, we give you the code book. And we say, how far can you support an EMT conduit from the code book and from the box? And here's the code book. Know where to find it. That's how we test them in German masters. So if you know how to use it right now, and if you go one article, it's typical. All of them are laid out the same way. Any comments, any questions, guys, about this article? So do me, I know a lot of you guys, Chris and everybody else read Please read what this chapter gives one time, especially if you are working in an electrical contractor. There's a lot of good stuff that you can learn from it. And that's it. Comments, questions for Chad? Aladipo, my friend. Tomorrow, guys, we're going to have a speaker, and the day after, I have a class about motors. We're going to talk about motors. So, thank you.